Hey guys, I've been seeing a lot of owners on the CPro owners forums recently, and a lot of you have questions about how the electrical system works, or you've had a dead battery and you don't quite understand why it happened. And so rather than see you guys have to take the boat back to the dealership, which are almost all busy right now, and do without your boat for a month or call a towing service, let's take a few minutes and walk through the features of the CPro Bay boats and talk about how the electrical system works to hopefully prevent any issues. So let's start our little tour in the back. Let's look at the battery compartment. So all of the boats come with two batteries, and you can see we've got battery 1 and battery 2. I recommend using a labeler and just label them. What you're going to notice off each battery, you've got one big terminal that leads to the ACR, and you've got one that will lead to the battery switch. A couple of the things you see on mine, the brown wires go to the bilge pump, and then the extra red lead that's thicker, this is actually the battery charger. We'll talk about that when we get to the center console. So if we tuck in here, and I apologize for the shaky video because it's hard to see, we've got a couple things. You can see that all of the grounds are coming back to here and they share a single ground for the whole boat. You also see that there are two red terminals. It's kind of hard to see on mine just because there's a lot of accessories installed. One goes to all the house stuff and the other goes to the engine. The engine basically goes up to the battery switch and then comes back down to here whenever the battery's turned on. Same thing for the house battery. The ACR is hard to see. See if I can get a decent shot of it. It's right there. We're going to talk more in detail about that in 1 second because that's where a lot of the confusion for you guys comes from. All right, so now let's go ahead and open up this awesome console and take a look at what we've got. So you can see we have the battery switch and there's four main areas coming off. What this is, you've got the house side and you've got the cranking side. We'll talk a little bit about how that works. I've got a couple additional accessories for things that I'm testing, so you can ignore that for now. All of that basically either goes up here into the T-top, which handles all of your lighting, or it will come up this gang of wires all the way to the dash. Once we get to the dash, every accessory has a circuit breaker, which is just push. It's a manual reset if it ever trips. And you've got your switches to turn it on or off. Up here, let's fold the seats up. We have a battery switch. For 99% of operation, you simply want to turn that to on. We'll talk about when you use combine here in a minute. I'll go into more detail with a wiring diagram. Anytime you're not using the boat should be off. That's pretty much it for the wiring system, and we'll talk about how to troubleshoot that. The next thing we just want to point out, one option you can either do from the factory or have your dealer install is to install a Shore power port. And so this is just a power port that goes into the center console and allows your battery charger right there to keep a trickle charge on your batteries. It's super critical with lead acid batteries that you always maintain a charge. Mine also goes all the way up to the trolling motor compartment. And you can see here that the trolling motor also has its dedicated battery, as well as the 3 batteries to reach 36 volts, or those of you that have the 208, 228 series, you might have 2 batteries for a 24 volt. These wires run all the way up to the trolling motor port. If you ever have to replace them, what you want to do is you would just take out the batteries here, look directly under, and it's actually a clean run all the way up under the anchor storage. It's really easy to replace this wire. So now that we've done a system overview, let's talk a little bit about the back end system. And what I mean by that is everything from the battery switch backwards. 2 exceptions, I've got the SIMRAD here, and this represents anything on the T-top or on the dash. And I've got the motor here, which is required for cranking and upstream of the battery as well. Quick overview of the components. We've got the motor here, so this is going to take from the battery to crank. It's going to charge the batteries when it's running. We've got our 2 batteries, 1 house and 1 cranking battery. We've got our alternate charging relay. We'll talk in depth about that next. We have a battery switch, which is a crucial piece to use the ACR correctly. We have a battery tender, which basically handles charging the batteries on a trickle charge when the boat's not in the water or being used. And then we've got our electronics that we just talked about. So the first thing we'll do here is let's just show that the motor actually charges the cranking battery. So you can see that's the way that goes. The next thing that happens is both of these batteries connect to the ACR. And this is a two-way communication. Next thing is the battery charger. You see it has two leads for each battery, so both of those just go to the batteries that they're respectively connected to. Next thing that's kind of confusing, I think, a lot of new owners is how this switch works. So if you look at the switch, you've got two modes. One is on and one is combined. And let's talk a little bit about how they're connected and what that means. So as far as they're connected, the cranking battery goes to one side. The house battery goes to one side. And what I want to point out here is there's a clear division between this side and the other side. So then what happens is the other post goes to the motor so that it can start, and then the other post here goes to all of your other electronics. All right, so how the switch works. When the switch is in the on mode, there's clear division between these two. So what that means is that this post is connected to this post, so your motor has access to the battery, and that this post is connected to this post, so that all other electronics are connected to the house battery and not the motor. That's important because you don't want the house battery draining the motor whenever you leave a sandbar and find out you've got no power. Now, if for whatever reason the cranking battery were to die, let's say it drops below 11.2 volts or whatever your motor requires to start, you can switch to combined mode. And so what that would do is that would draw from the house battery and average the two out. Okay, so now let's dig into the ACR, and this is where a lot of the confusion happens, so let's talk through it. We'll start with some basic 12-volt battery information. I don't know if you can see this here, but a fully charged 12-volt battery will range anywhere from 12.8 volts up into the 13s, just depending on your battery technology. Fully discharged is around 11.8 or 11.9 volts. That varies. Also, it varies what your electronics will accept. And then anytime that the batteries are charging, generally it's at least 14, maybe 14.5 volts or higher. Some of the more expensive, nicer chargers are smart enough to detect the battery technology and will charge different technologies at different voltages to protect your batteries. Next thing we need to talk about is what this little LED means. So if you notice, there's a LED right here on your ACR. So when that is on, the batteries are combined. And so what that means is that when the motor's running, it's actually feeding current to both batteries so that both batteries are charging, and hopefully neither will end up dead. If that is off, it means that it's isolated, so only the engine battery would be charging if it's running, or if you're drawing down, each battery is drawing separate, like we talked about with the battery switch, unless it's in the combined mode. So what we need to know, because it's important that you know this when you're troubleshooting if you're ever offshore, if the batteries are combined, one of two things has happened. Either the battery is at greater than 13.6 volts for 30 seconds. That should be true for most of the engines that are running. Or either battery is greater than 13 volts for 2 minutes. It shouldn't take that long with any of the new motors. Next thing you need to know is the battery separated. So if either battery drops below 12.75 volts, it separates the battery. So the use case here would be, let's say you've been running, your batteries are sitting around 12.8 or 13.1 volts. It combines both of those when you're sitting there listening to music or running your SIMRAD or radar. And then as soon as it drops to 12.75 volts, as long as your battery is on the on position, your batteries become separated so that your electronics will not cause you not to be able to start the motor. The edge case here is that either battery falling below 10.8 volts, which means the battery's dead and probably won't take a charge, the ACR will completely lock that out. And why that's important is if it's completely locked out, it won't charge one battery, so to limp home, you will always have to put your switch in combined mode to hopefully average those out. Now, one thing I will say, if it's this battery that's below 10.8 volts and it's the engine, it's possible that by combining them, you still don't have enough juice to start the motor. So what you might have to do is manually move the engine over to the house battery just to get home. Hopefully that doesn't happen if you're paying attention, but it could. So in summary, let's say that we're cruising along. As long as the alternator is working, both batteries are charging. Once we get to a sandbar, you should have around 13 volts in your battery. It's going to keep both batteries combined no matter what the battery switch is set to. As soon as you hit 12.7 volts, it's going to isolate the two batteries so that the house battery supplies the house, the engine battery supplies the engine. If at any point you drop below 12.1 volts for either battery, I would recommend setting a SIMRAD alarm so that that's brought to your attention, because when you start getting too low, you might not even be able to start your electronics or your engine by combining them. So you definitely want to make sure that you have your alarm set up so that you're not constantly having to monitor the batteries. That's basically it for the ACR. There's not a whole lot of magic, but I think just the fact that it's always switching states is what confuses a lot of people. So the next thing I wanted to talk about is how do we troubleshoot whenever there's a failure upstream of the battery switch? And the reason I wanted to talk about this is I see a lot of people on the forums guessing and checking as to what might be wrong with their electrical system. And that's not terrible whenever you're in the garage, but a lot of you guys are going offshore, and it's really important that you know how to safely troubleshoot your electronics to get everything back working and get you and your family back home safely. So what I've done is I've built a basic circuit, and I've just made a short little pigtail circuit here so that we can identify all of the components that would normally be used on the C-Pro Bay boat without having to dig in through all the wiring behind the console. I think it's easier to see this way. So let's talk through the components and what their purpose is and kind of why we have them here. So the first thing I'm going to start with is the end, and so this would be connected somehow to the battery switch, or if it was a bilge pump, it'd be connected directly to the battery. The logic here is going to follow for every electrical system on the boat. Next thing we've got is we have a manual reset circuit breaker, and what this does, if you look on your dash, you'll see some little rubber buttons. And what happens here is if anything downstream were to short out, meaning it could cause a fire if the wire gets too hot, this little switch is going to pop out and it disconnects the battery source from whatever's upstream. Super critical, especially around fuel, that you don't disable this type of functionality. So what you would do in a normal situation is if it just happens once, you're probably safe pushing the button, and that's going to re-energize the circuit and you'll have power back here. The two other things you'll see is you'll see a basic fuse. This is what you would have on a car. It's what you have for your T-top, or you'll have an inline fuse. This is what the bay boats come with for the bilge pumps. Not a whole lot of difference between a circuit breaker and fuse, other than once a fuse fails, it fails permanently, so you have to have a replacement. A circuit breaker can be manually reset. Benefits to a fuse, they typically don't trip as often incorrectly, where circuit breakers every now and then will fail when they really shouldn't have, especially if you've got an electric motor like a bilge pump behind it. So that's why you'll see the bilge pump with a fuse. The next component we have is just our basic switch. This is the switch that you see on the dash. You just flip it, and all it does is it just connects these two. So from the circuit breaker coming in, it connects the downstream. And then I've got a basic light here, but this would be the same for a SIMRAD, for your nav lights, radio, literally any electronic on the boat. And then finally, I've got a ground wire. This is just a piece of brown wire I had to represent the ground, just to demonstrate. So the first thing you want to do when you're troubleshooting any DC circuit is you want to get any voltmeter. This is just a cheap $5 Harbor Freight one. And so you want to set it to DC voltage, and you can see here that it's on the number 20, meaning it goes up to 20 volts. So we're going to flip this on. So we can see here it's reading 0. So the first thing you would do is find any ground on the boat. They're all shared. It makes no difference where you clip your ground off to. And just go ahead and clip this guy off to the ground so that you can get your full circuit. Then when I'm troubleshooting, what I like to do, just order a priority, or really just order of how easy it is I'll go behind the dash, find the circuit breaker, which is below the switch, and I'll simply touch this with it grounded to the incoming feed. So in this case, you see we've got 0 volts. If this was above 12 volts, then we know that everything downstream of here has been ruled out. If it's negative 12 volts, don't worry about that. That could just mean you've got your positive and negative flipped around on the voltmeter. It's not a big deal. As long as it's 12 volts, it's 12 volts. Then the next thing you do is methodically work your way through the system. So what we would do is we would go ahead and touch the upside of the downstream side of the circuit breaker. If we still have 12 volts, we've now proven the circuit breaker is good. Then what I would do is I would work my way up to the switch. touch the switch. If the incoming is good, we've now figured out that the wire that connects these two has not been broken, and we verified its continuity. Next thing I would do is I would go ahead and touch the switch here. If we don't get any downstream voltage and the switch is on, then we know the switch is faulty. If we do get downstream voltage, then we know the switch is good. I usually flip it both ways just in case it rotated upside down in the dash. Then finally what you'll do is you get next to your component and you'll want to touch the latest connection point you can. You might have to disconnect where the wire was crimped and then recrimp it, and just make sure you're getting 12 volt there. If you are getting 12 volt there, you've basically told yourself that the light or SIMRAD or whatever the device is faulty. Now, with lighting, it's not super sensitive that it has to be exactly 12 or 12.5 volts. With the SIMRAD, if you're dropping below 12 volts, chances are you're gonna get some really sporadic behavior. And I'd say anytime that your electronics aren't acting consistently, more than likely it's not a continuity issue, it's a problem that your batteries aren't holding a full charge. So taking a step back, what we need to do is, let's say for whatever reason we tested here and we were getting 12 volts coming in, and on the way coming out we didn't get 12 volts. First thing we do, like we talked about, we tap the circuit breaker and reset it. If that doesn't fix it and we're not getting 12 volts, we want to go ahead and disconnect the wire. And I'm going to move all this out of the picture. And let's bring back in our fuses so we can talk about those. All right, so then what I do, the little alligator clip doesn't need to be on the ground anymore. So what I do is I remove that. And I think it's easier to test switches with straight pins. So now we've got our positive and negative plugged in. Then what we want to do is we want to go down to ohms. So quick lesson, voltage, what we measured before was the gap in voltage between the positive and the negative. So we gained 12 volts. Ohms is basically saying how much resistance is between the two. So right now we have a 1, which means there's infinite resistance, meaning there's no continuity between these two. If we touch them, we want to verify that that goes down to 0, meaning there's no resistance, so we've got current flowing all the way through with almost no loss. So what we do here, we want to go ahead and touch the bottom of the circuit breaker to the top. And we can see here that there's 0 resistance at all. Just to show you this works the same. If we were to work on the fuse to the T-top, we touch both ends, it shows 0 as well. If we were to test a bilge fuse, these show 0 as well. Now with fuses, you should be able to look right in the middle and see if it's busted, but never just trust looking because they can fail and it's really hard to see. So the next thing you can do, if that's not your issue and it's the switch, let's go ahead and remove. So with a switch, you want to verify 2 things. So we verified at this point that we have no resistance at all when the switch is on, and when we flip the switch off, we've got infinite resistance. So anytime you test a switch, you want to make sure both of those work so you're not leaving stuff on, draining the battery unknowingly, but you also want to make sure that it works the other way. Next thing we'll test is, let's say between the circuit breaker's downstream feed and the incoming on the switch, let's say if you're getting 12 volts here and you're not getting 12 volts here, you test what's in the middle just like you test any of the switches or the circuit breakers. So you'll test the wire and you want to connect both ends. And you can see here I have no resistance at all. So that tells me this wire is good. The scenario we described of voltage coming out here, voltage not being here, you would expect that this would show a 1.0, or if the wire's starting to rust, it might show a 0.5, meaning you're losing voltage. So you know you just need to replace the wire. One thing to note, if you need longer leads, you can always extend them or order longer ones on Amazon. Sometimes, just with how tight a boat is, you're gonna need longer than what comes with it. Okay, that's about it for troubleshooting literally everything upstream of the battery switch. It's that easy. So just a quick review if we look at our components. The first thing you always want to test, just because it splits the middle, so your troubleshooting time will be less. See if you've got voltage coming into the circuit breaker. If you don't, you know the problem is the battery switcher back. If you do, the only things that could be failing are the circuit breaker or fuse, the wire between each link, the switch, or the device itself, and we've talked through how to troubleshoot all of that.